Hi everyone, welcome back to my channel. Today we are continuing our GeoPandas series. In this video, we will dive into one of the most important components of Pandas, the data frame. By the end of these tutorials, we will understand what Pandas data frame is, how to create one, and some basic operations you can perform on it. Let's get started. In our previous video, we covered the Pandas series, which we said is a one-dimensional data structure similar to a single column in an Excel spreadsheet. A Pandas data frame, on the other hand, is two-dimensional, meaning it consists of rows and columns, like an entire Excel spreadsheet. So if a series is a single column, then data frame is a table made up of multiple columns. This means a data frame is a collection of series objects that share the same row index. If you haven't watched the previous video on series, I recommend checking it out because many of the functions and operations we discussed in that video applies in data frame, and we will not be going over that again. Now that we know what a data frame is, let's learn how to create one. Just like series, there are multiple ways to create a data frame. In these tutorials, we'll use traffic data from a road in Accra, kindly provided by a friend. So the first method we'll be going through is creating a data frame from a dictionary. In this method, the keys of the dictionary represent the columns of the spreadsheet, and the values, which can be in lists, tuples, or series, represent the data in each column. You can see the table that we get from the data above. So the next method we'll be looking at is creating a data frame from a list of dictionaries. In this method, each of the dictionary represents a row, and the keys represent column labels. If we run this column, we can see that we have the exact same table. Another way to create a data frame is by creating it from a list of lists. So here, each list represents a row of data, and you define the columns named separately. So we used two rows to demonstrate the idea. If we run it, we can see this is exact same table. So instead of 5 rows, we have just 2. We can also create a data frame by combining multiple series objects. We are creating individual columns as their own series, and then here we concatenate. That means we combine all the columns together to create a data frame. So as we said, data frame is just a combination of series. When you use this method, you need to pass axis of 1. By default, concatenate combines along the axis of 0, which appends the series by rows. Here, all the series represent columns, so we need to make it axis of 1, which basically means appending the series by the columns. And with that, we just have our data frame. If we run this, we see the exact same table. And another way to create data frame is from loading it from a CSV file. So in this case, if I extend my sidebar, I can see we have the data here, or your Jupyter Lab interface. So after you've done that, you can then load it using the read CSV. So CSV is not the only file that we can load. We can also load Excel, JSON, and SQL file. But CSV is the most common way of loading data into Pandas. When we run the code, we have all the data in our CSV. Once you've created your data frame, it's time to inspect the data. The head column is going to show you the first 5 rows of your data frame. We can also decide to display or to show the last 5 rows in our data frame. In that case, we use the tail method. We can also specify the number of rows to display. To do that, we just have to insert the required number in the parentheses of the head or the tail method. Here, we are specifying 10 for the head, so it is going to display the first 10 rows. And here we are going to specify the last 8 rows. Run the cell, we are given the last 8 rows. So that's it for viewing data with Pandas. We can easily retrieve information about the labels and data types in our data frame. So to retrieve the row labels, we can use the index attribute to do that. We said it in our previous video that by default, the row index tends to be an iterator from 0 to the length of the data frame in this case. We can also decide to display the column labels. We have a list of our column label. We can also decide to retrieve both the column and then the row labels. So to do that, we use the access attribute. So here we first have the row label and then we have the column label. We can also retrieve data type of each column. So in this particular case, we have objects as our data type because either Pandas is interpreting the columns as a string or mixed data. So it is a flexible way for Pandas to present our data, but for performance reasons, it is advisable to convert the data type of your column into a much more appropriate, a much more fitting data type like int, float, date, time, etc. We'll go through how to do that in the next step. The info method gives us a summary of our data frame, which includes the type of our data frame, the row index, the column, the total number of columns, and then the total number of rows. Then we also get the number of non-null values, the data type of each of the columns, and then the memory usage of each of the columns. With the info method, you get a general overview of your data. It's always good for data analysis. So as we touched on in the previous cell, if we want to change the data type of a column, there are two main ways we can do that. We can use the asType method, or we can modify the column in place. We'll demonstrate how to do the two. So here, we will first change these 3 columns, the route, direction, mode of transport, segment, data type to category. The reason why we are changing it to category is that category data is very good for improving memory usage and performance. So the next column that we'll be changing is the date. We will convert the date column into a date time for easy date manipulation. The next columns that we'll be changing is the start time and stop time, which will be converting them into date time, but we'll only be keeping the time portion of the date time. We'll get back to this line. The last column that we will be changing is data type is the duration, where we'll be converting it to time delta for easy time arithmetic, which will allow us to perform operations like summing durations, calculating averages, etc. We just run this code and then we get an error, right? The reason why we are getting an error, the duration holds hour, minutes, and seconds, but some of the values just have the minute and seconds. They are no hour. So that's what's causing the issue. A way to solve that issue, with this line of code, we are adding 00 to the line that don't have the hour, that just have the minutes and second. When we run this code, it works perfectly now. Now we can see that the info gives us a different data type for each of our columns than we initially had. And then we can see that the memory usage has changed, right? We have decreased the memory usage by giving it appropriate data types. So here we had a memory usage of 2.9 plus kilobytes, and we have reduced it to 2.4 kilobytes, which is great. So the final cell we're looking at is how to get dimensions of a data frame. So to check the number of dimensions, we can use the ndim attribute. When we run this code, we'll get 2 as the number of dimensions because it's a data frame. We said that the very definition of a data frame is that it has 2 dimensions. And so if it was a series, then it would be 1 dimension. We can use a shape attribute to check the number of date values across each dimension. When we run this, we'll get 50, 70, meaning we have 50 rows and 7 columns. The final attribute we'll be looking at for this tutorial is the size attribute, which gives us the total number of data values in our table. So when we run this code, it's going to multiply the 50 by 7 to give us the total number of values in our table, which will be 350. That wraps up today's video. We've covered the basics of creating and inspecting Pandas Dataframe. Moving forward, we'll be doing deep dives into functions and operations that make Pandas so powerful for data analysis and manipulation. If you found this tutorial helpful, don't forget to like, share, subscribe. And if you have any questions or topics you would like us to discuss, drop a comment down below. Thank you for watching. I'll see you in the next one. Stay curious and keep learning. Bye.